Hey everyone, welcome back to the channel. If you're getting ready for a .NET interview, you know that nailing the fundamental is key. We all love the power and speed of .NET. Let's understand the native AOT compilation. So today we're just going to talk about performance aspect of native AOT compilation. This is your chance to get ahead of the game and show your interviewer that you're not just a coder, you're a smart coder. Remember, .NET is a huge ecosystem, and covering everything in just one book is impossible. That's why we've put together a curated list of 4 essential books to give you a truly holistic view of the most common interview topics. You'll find the links to all of them in the description below. Also, with the modern development landscape, it's crucial to be prepared for more than just back-end questions. We've included links to books on Azure development and essential front-end technologies, which can significantly boost your chances of landing that dream role. So go ahead and check out those resources, and good luck with your preparation. With the recent release of .NET 9, Microsoft introduced the Hybrid Cache library to simplify and optimize application performance. Interviewers are using this to test if developers are staying up to date with the ecosystem and if they understand the complexities of distributed systems, specifically cache stampedes and multi-tier caching. We're about to dive into the questions, but first I want to hear from you. What's the one interview topic that always makes you nervous? Drop a comment below and let me know. And if this video helps you, hit that subscribe button and ring the bell so you don't miss our next deep dive. So let's dive into our today's topic. With the recent release of .NET 9, interviewers are moving beyond basic questions. Instead, they are focusing on how to reduce cold start times and memory footprints. What is native AOT in .NET, and how does it differ from traditional JIT compilation? When should you avoid using it? Native AOT compiles your .NET code into a self-contained, architecture-specific native binary at build time rather than compiling it to intermediate language IL that is translated by the just-in-time JIT compiler at runtime. Key benefits: instant startup. No JIT compilation at startup means the app reaches full speed immediately. Reduced memory. The app doesn't need to load the JIT compiler or store IL metadata, significantly lowering the working set. Small deployment. The binary includes only the specific runtime code your app actually uses via tree shaking or trimming. In a traditional .NET app, the JIT compiler optimizes code based on the hardware it's currently running on. While powerful, this takes time and CPU during startup. Native AOT shifts that optimization task to the build server. However, it introduces AOT incompatibilities because the compiler must know every line of code that will run at build time. Features like reflection, dynamic loading, and runtime code generation are restricted or require special configuration. To enable native AOT, you modify your project file, .csproj, and ensure your code is trim compatible. AOT-friendly code. Example: native AOT requires the compiler to see types. Instead of using traditional reflection-based JSON, which fails in AOT, you use source generators. When to avoid native AOT. You should not use native AOT if your project relies heavily on third-party libraries that use reflection, like older versions of AutoMapper or Newtonsoft JSON. Requires runtime plugins, loading DLLs dynamically that weren't known at build time. Uses Entity Framework Core with certain dynamic proxy features, though EF core support is improving rapidly. Hope this makes a clear understanding. See you in the next exciting video. Check out the detailed video on these topics, link given in the description box. Subscribe our channel for .NET interview preparation.